This is on surds. What do we mean by surds? When we are unable to simplify a number in a root, we call it surd. For instance, if I have square root of 5, 5 is not a perfect square. So that means I cannot get the square root. So this is what we refer to as surd. So we have some basic rules that guide surd. Root a plus b is not equal to root a plus root b. That is, if we take our a to be 9 and we take our b to be 4, 9 plus 4 is 13. Square root of 13 will be 3 point something. Now, root of 9 is 3. Root of 4 is 2. 3 plus 2, 5. So we can see that they are not the same. The same thing is applicable to subtraction. If you have subtraction in the root sign, by the time you split them, they will no longer give you the same answer. It is only multiplication and division that can give us the same answer. That is, if I take my a to be 9 and my b to be 4, 9 times 4 is 36. Square root of 36 is 6. Come to the right hand side. Square root of 9 is 3. Square root of 4 is 2. 3 times 2 is 36. So that means I can split multiplication and I can also split division. When we get to where some of these things will be applied, we'll understand better. Now, let's take some examples on how to simplify surd. It's not every time that we have a figure like this in surd that it cannot be broken down. Sometimes we can get something out of them, then the rest will remain in the root. But for us to do this conveniently, we must be very, very familiar with perfect squares. What do we mean by perfect squares? Numbers that we can express as a square of another smaller one. Like 1 is 1 times 1, so 1 is perfect square. 4 is 2 times 2, 4 is perfect square. 9 is 3 times 3, 9 is perfect square. So these are examples of perfect squares. We have some on the board here. 1, 4, 9, 16, 25, 36, 49, 64, and so on. So these are the perfect squares that we'll be making use of in simplifying surd. We have root of 48. We have to simplify root 48. So what we need to do here is to check the perfect squares. Which of those perfect squares can divide 48? Sometimes we can have more than one of those perfect squares that will divide 48. We have to take the biggest one. For instance, this 48 now, 1 is a factor of 48. 4 can also divide 48. 16 can also divide 48. So that means among these perfect squares now, I have 1, 4, and 16. And if you check, 16 is the biggest among the 3 of them. So I'm going to take 16. So if I divide 48 by 16, it will be 3. That means 48 is 16 times 3. If I divide 48 by that 16 I want to use, it will give me 3. So now I will express 48 as 16 multiplied by 3. So now that we have broken them down into 2, we can see that 16 is a perfect square and the square root of 16 is 4. So that means I'm left with only 3 in the root. That is how to simplify surd. You take the square root of the perfect square out, then you'll be left with the other number which is not the perfect square. 147. So we'll check among these perfect squares which one can divide 147 without a remainder. So if you have more than one, we'll pick the highest of them, like we did in the first example. So this 147, 49 will divide 147. So that means my 147 will be 49 multiplied by 3. We just simply divide 147 by 49. That will give us 3. So square root of 49 is 7. Then we are left with 3 in the root sign. The third example here, we have 50. So among these perfect squares, 25 is the only one that can divide 50. That means we'll take 50 as 25 multiplied by what? That will give us 50. That is 2. 50 is 25 times 2. So now we'll take the square root of 25, which is 5. Then we'll be left with only 2 in the root sign. So this is how to simplify surds. We just have to be familiar with the perfect squares so that it will be very, very easy for us. And don't forget, when you divide by a perfect square, for you to know if you have used the right perfect square, after dividing 48 by 16, the answer you get must not include another perfect square. That is, it must be a number that we cannot get another perfect square from. So 3 is not a perfect square, and there is no perfect square apart from 1 that can divide 3. So that's how we will leave 3 the way it is. Thank you.